Good morning, student. As you already have learned the first chapter, which is force, today we are going to see the second chapter, work, energy and power. We are going to see what is work, what is energy, what is power. We are going to see what are the definitions for them and how do we mathematically calculate them, mathematical expression. Then we'll see the numericals and all. Okay, so first what are we going to start with? We are going to start with the work. When do we hear the word work, what do we understand? You all think in your mind, like work is something when we do some mental activity or when we do some physical activity, that's basically we call work. So how we elaborate work here, or what is the definition here? So like if I'm gonna take a body here, or how we describe work here in physics, if we take a body and we apply a force on the body, let's say we are applying a force F Newton on a body, it could be anything, 10 Newton, 5 Newton, 4 Newton, this F Newton on a body, what do we see? We generally see that the body will have some displacement. Like if I'm having a body here and we are going to apply a force on the body, what do we see? That there is a displacement in the body, so we'll see some displacement. So how we draw the definition is simply work is force into displacement, that when we apply force there must be some displacement. But here is a key point which you should know, that when we are talking about work, we are applying force on a body and there is some work done, the displacement in the body should be in the direction of force. Whenever we apply force, the displacement whatever we are taking or considering, it should be in the direction of body. This is a key point which you always keep in your mind, that the displacement in the body should be in the direction of force. So if we assemble the whole definition again, on a body, if we apply force and there is a displacement in the direction of force, then the product of force into displacement will give you certain amount of work done, that is W is equals to F into D, and that's when we say that force into displacement. Now if we see that what happen if we see any body in which we apply force but there is no displacement, what happen if we apply force but the displacement is in some other direction or at any other angle? So then how are we gonna calculate the work done? Before that, if you see here, work is equals to force into displacement. If you want to see the unit, like as we have written, W is equals to F into D. If you want to see the unit of work, F is Newton, we know, and displacement, the unit SI unit is meter. So the unit is either Newton meter or also we calculated in joule. So that's the we already know that the unit of work done is joule. It can also be Newton into meter, as F into D. We can write this this unit. Okay. Now let us come to see. We already have seen the mathematical expression for that. Now let us see what are the types of work done. Or if we are having a body, let's see, we are having a body, and what if we apply force in a forward direction? Here we are applying force in the forward direction, but we are getting displacement in some other direction. It's not a proper example. You can talk about like this. We can take another example. If a body is moving on an inclined plane, I hope you all can understand, like we are having a horizontal line and we are having an inclined plane. So this is your horizontal line, this is our body, and if it is moving on an inclined plane. So let me show you, if there is a body and it is moving, here we are applying a force. So now you can see here we are applying force and the body is moving in the upward direction here. So if you see that the force here, what we see that the direction of force and displacement, they are in the different directions. So but what definition we have learned? We have learned that the force and displacement should be in the same direction. So how are we gonna resolve that problem? So let's see. Okay, so let's see that here, let's say we are having a direction of force here in this direction, and we are having direction of displacement. It's simple that on a body the force is acting in this direction, the displacement is acting in this direction, and if you see they are in two different directions. Let's say that they are at an angle theta. Now according to the definition, if we want to calculate the work done, it must be force into displacement, but the displacement and the force should be in the same direction. So how are we gonna take them in the same direction, or how are we gonna bring force in the direction of displacement or displacement in the direction of force? So here is the idea. What are we gonna see? F and D are at an angle theta. We are gonna take this F and we are gonna find the component. Here these are the terms which are going to be new for you all, that we are taking the component of F in the direction of D or D in the direction of F. A very small example I want to give you all here so that you will learn what is the meaning component here. It's those who are getting it, those who are gonna get it, that's good enough. If you are not getting it, no problem, you will understand. Okay, now if I ask you all, if you take a simple body and you throw the body, like this is called, you learn in further classes, that if you throw the body, what you will see, that this body will not go horizontal, but this body will cover a path like this, isn't it? This is a projection of the body. So if you see beta here, the body at the same time is attaining some height, like body is moving up, so that means the body is attaining some height. Also the body is moving in the forward direction, isn't it? It is going in the forward direction because from here it is going till here, and it is also attaining some height. So that means here the body is doing two things. One thing is body is moving in the forward direction, and body is also moving in the upward direction, and for that we need two velocities, but we only have given one velocity. No, we only have thrown the body with one velocity. Like let us say we have thrown the body with the velocity u. So now here is the point. When you throw the body with the velocity u, there is a two component, or there are two components of the velocity which gets break. That is, one, it is known as horizontal component, and this one is known as vertical component. That means you always have two effect of the velocity. One part of the velocity is taking the object in the forward direction, one part of the velocity is taking the object in the upward direction. So if you see, it is going in the direction, it is going up also. So one component, now here I am going to take the word one part, or you can call it one component. One component is taking it in the forward direction, one component is taking it in the vertical direction. So that means the velocity is now splitting into two parts. One is the horizontal component, one is the vertical component. So these are the effects you call it, and that's what we call it component. It is still the same velocity but having two effects, and that effect are called the components. And this is the same thing we are gonna do here. Now see, here we have in this direction, horizontal direction, let's say this is the direction of our displacement, this is the direction where our force is acting. They are in two different directions. Let us say they are at an angle theta. Okay, and after that what we are gonna see, we want F either in the direction of D, because those two should be in the same direction, or D in the direction of F. You can do any of that thing. Okay, so now for that what are we gonna do? Here if we draw perpendicular, this is going to be 90 degree. Let's name it. It's A, B and C. Now if you see beta, this is your 90-degree right angle triangle, this is your hypotenuse, this is your base, and this is your perpendicular. According to or you can say in the direction of hypotenuse, we are representing force. We want this force in the direction of base. This is your base. We want the component of force in the direction of base. So we want base. We already know that hypotenuse, along hypotenuse we are representing force. So we have something on hypotenuse, we want something on base. So if I ask you a trigonometrical ratio which relates hypotenuse and base, that would be cos theta. If you can recall, cos theta is actually base upon hypotenuse. That is base, you all know, we already have learned, base upon hypotenuse. What is our base? This is our base. Base is AB. Upon what is our hypotenuse? That is AC. And here we have our cos theta. Now if you bring this AC here, so that will be that AB will be equals to AC cos theta, isn't it? Because AC is here and it will come here and it will get multiplied with cos theta, AC cos theta. Now AB is our base, that's what we wanted, so we are writing it like that only. AC, along AC, which factor we are representing? That is force. And here we have cos theta. AC, on AC we are representing force and cos theta as it is. Now we know that AB is F cos theta. That's what we have already calculated. Now we are gonna see the definition of work done, and let's see. Okay, so I'm gonna write it here. According to the definition, work done is the product of force and displacement, but both of them should be in the same direction. So first I'm gonna write it like that, force into displacement, but both of them should be in the same direction. That's what I am telling it continuously, they should be in the same direction. So if we are taking force and displacement, we should be taking the force and displacement which are in the same direction. So here if we are taking this as a direction of displacement, force should also be in the same direction, because displacement we have already taken in this direction. So this force F, we have break the effect of force, which we call it component, is actually F cos theta. So along this, which force is acting? F cos theta. So if you see in the forward direction now, if you see which force is acting, not F, but the effect of force, that is F cos theta. You can call it the component of force F cos theta. And because of this force, what is the magnitude of displacement? That is D. So force is not actually F, but now the force is F cos theta into displacement we are taking D. So here if you take F D and then we write cos theta. So this is the proper mathematical expression for work done, that is F D cos theta. F is the force, D is the displacement in the direction of displacement in the direction of force, and cos theta, here theta is the angle between force and displacement. Keep this in your mind beta. Here force and displacement, it is the angle between force and displacement. I hope it is clear. So here are some key points. Like if we talk about the work done should be the product of force and displacement. The displacement should be in the direction of force always. And if the displacement of force and displacement are at a different direction, let's say at an angle theta, 60 degree, 30 degree, 40 degree, 0 degree, 90 degree, then we say that the magnitude of force will be Fd cos theta, and the value will be changing depending upon the value of theta. So till here we have defined, or we have calculated the mathematical definition of work done. So I'm gonna write the definition freshly here. we have drawn the definition of work done is mathematical definition actually, F d cos theta. Again I'm telling you all, F d cos theta, F is the force, d is the displacement, and theta is the angle between the force and the displacement. Depending upon this mathematical definition which we have derived, we can now categorize work done into three categories or three types. The first one is positive work done, second one is negative work done, and third one is zero work done. We already have seen the unit of work done, that is Newton meter, and the unit also is joule. Now let us see what is a positive work done. Positive work done. Okay. Now, beta, if we see that force, as I have already told you, that if the force is acting in this direction and displacement is at a different direction, and let's say the angle between force and displacement is theta, okay, then depending upon the value of theta, we categorize work done, and first one is positive work done. If the angle is between 0 degree to 90 degree. I hope you all know what is between 0 degree to 90 degree. Like if we see the coordinates or quadrant, which are, this is the first quadrant and this is the angle between 0 to 90 degree. That means the force and displacement, they can have a maximum angle of 90 degree and minimum angle of 0 degree. Then we say that the work done will always be positive. I am telling you an example. Like if we are having force acting in this direction, displacement acting in this direction, and the angle between them is 30 degree. That means what is the value of theta? That is 30 degrees. So if you put the value here, W is equals to F d cos 30. So whatever the value of F given, we'll put the value of F. Whatever value of D given, we'll put the value of D. And same, what is the value of cos 30? I think you all can remind what is the value of cos 30. I'm not going to tell you all remind. Okay, F d cos theta, cos 30, cos 60, whatever it is. So we'll put the value here. By the way, it is root 3 by 2. So that's how we say that the work done is going to be positive. We have many examples. Like if you have seen a grass cutter machine, I hope you all have seen a grass cutter machine, beta. Here is a sort of a handle, and when you hold the handle, you apply the force like that, and the displacement is in that direction. So displacement is in the forward direction, force you are applying here, so you can see the angle between them. Or you can see, there are many examples. If something is climbing, like if you are having a body on an inclined plane and the body is moving in the upward direction, that means force, not the force. If you are applying force in this direction, in forward direction, this is the direction of force, and displacement is in this direction. So angle between this is theta, and then you can see that the theta is between 0 to 90 degree, and then the cos 30 or whatever cos theta will always be positive, giving this whole value as positive value. Okay, so this is how we are having positive work done. Now the second type of work done is negative work done. First one was the positive work done, second one was or is negative work done. Now negative, I think you all understand. Negative means a value is going to be negative. How it is going to be negative? When theta is more than 180 or theta is 180, exact value 180 or more than 180, then we say that the value of work done will be negative. Like if you see, beta, you can take an example. If we are having a body here and we are having a body here. Now see properly, if you are having a body here and if we are throwing the body in the upward direction, okay, we are throwing the body in the upward direction, so we are applying force in the alarm, stop it. Okay, so here we are having a body, and if you see better here, we are going to see the negative work done. If you are having a body here and the body we are throwing in the upward direction, okay. Acha, by the way, when the body is throwing or we are taking the body in the upward direction, can you guess in what direction the weight of the body will be acting? Yes, the weight of the body should be acting or will be acting in the downward direction. So the weight will always, what is weight? M into G. You all know that is M into G will be acting in the downward direction. But the body is moving in the upward direction. That means the displacement is in the upward direction, isn't it? The body is moving in the upward direction, but the weight is acting downward. This is the body, the motion of the body against gravity. This is the example of the body moving in the upward direction. We call it the motion of the body against gravitation. So here we are gonna write the definition of work done. So now work done will be F d cos theta, and theta is the angle between force and displacement. So now if you see beta, force, that is gravity you can call it, or weight is acting in the downward direction. So F is in the downward direction, D is in the upward direction. What is the angle between the two? Here you can see the angle between the two is actually 180 degree. So that means if you are going to put the value, it should be cos theta. Theta is 180 degree exactly. So here we have W is equals to F D. And if you see beta, cos 180 is minus 1. Like the value of cos 180 is minus 1. We already have learned the trigonometric table, that is a value of cos 180, cos, not 180 you have learned, but you have learned till 90, no? So that's how we calculate the value of cos 180. You learn how we calculate. Now FD minus 1. So here you can write it FD minus FD. Cos theta, so we have already kept the value here. So this is negative. Now if you see beta, the work done is now coming negative, and that's how we call it a negative work done. So whenever there is a motion against gravity, like a body is moving in the upward direction against gravity, why? Because if the body is moving in the upward direction, the gravity is acting downward. That means the force is acting in the downward direction, but the displacement is in the upward direction. So total angle will be 180, and if the angle is 180, cos 180 will become minus 1, and the work done will be minus FD. It will be negative. So whenever there is a motion against gravity, we always get the value of work done negative, and that's how it is called negative work done. There are other certain examples. This is for you to think. Can you give another example in which the work done you can find negative? I can give you one example. Isn't it? Have you learned about friction? Like where you all find out where friction, what is the direction of friction and what is the direction of displacement, and you see what is the angle between the force of friction and the displacement, and then you find out whether it is a negative work done or not. Okay, and you can find another example of a negative work done. Now we are going to see the third type of the work done, that is zero work done. Now we have zero work done. When we say zero, I think by the name you understand zero. That means the value is going to be zero. Can you tell me for what value of cos? For what value of cos we have the value 0? Which angle? For which angle of cos the value is 0? Excuse me. Here we have the definition FD cos theta. For which value of the angle the cos will become 0? Can you guess or can you tell me? That is cos. So here, if you see beta, the direction of, let us say the direction of force is in this direction, but the displacement is in direction. What is the angle between that? 90 degree. That means when theta is 90 degree, if you put the value FD cos 90 degree, when the force and the displacement, they are in perpendicular direction. So W is equals to FD cos 90 is 0. So W will be equals to 0. So this is how, when the angle between them is 90 degree. Now let's quickly see the example for that. Okay, now what happened when your mother asked you all to bring a bucket of water, full with water, and then when you bring the water and you say, आज तो मैं बहुत थक गया या थक गई. But then I actually tell you, you are doing zero amount of work done for that particular instant, because when you are actually holding the bucket of water, beta, the force which you are against gravity, if you are applying, or you are just holding the bucket, the weight is acting in the downward direction. If you are talking about the weight, so that weight is acting in the downward direction. But when you are taking the body and you are moving in the forward direction, see, the weight is acting in the downward direction, but then you are moving in the forward direction. So force and displacement, what is the angle between them? 90 degree. Whenever the angle is 90 degree, the work done will always be 0, because FD cos 90 and cos 90 will always be 0. You can take another example. You all have seen coolies which they are taking weights, they carry weights and then they take the weights. Okay, whenever they take the weight and they put it on their head, beta, the weight is acting in the downward. Whatever weight they are taking and they are putting on their head, the weight is acting in the downward direction. The weight is acting in the down. That means whatever force is acting on their head or whatever is acting in the downward direction, and they are taking the weight and they are moving in the forward direction. That means the displacement is in the forward direction. So what is the angle again? It is 90 degree. So again the work done will become 90 degree. Okay. So that's how we have seen. There are three work done. Let us quickly recall work done. The definition of work done is, the work done is actually the product of force and displacement, but the displacement should be in the direction of force. And that's how we have designed a definition. We have derived a definition, mathematical definition. W is equals to FD cos theta, where theta is the angle between the force and the displacement. And also we have seen there are three types of force, three types of work done: positive work done, negative work done, and zero work done. Positive work done when the angle between the force and displacement is between 0 and 90 degree. When the angle is more than 180 degree or exactly 180 degree, then the work done will be negative work done, because cos 180 is -1. And when the angle is exactly 90 degree, that means the force and the displacement are in the perpendicular direction, then we say that this is the zero work done. Next, in the next video, we are going to see how are we going to calculate the work done against gravity, that is what is mg, potential energy related. We are going to see, also we are going to see some numericals. Keep reading and keep solving your numericals and problems.